Good morning children, welcome back to maths class. So today we will continue the lesson integers. In the last class we have studied addition, subtraction, multiplication and division of integers. Today we will be continuing the lesson with properties of integers. Properties of integers. First property is closure property. First property is closure property. Closure property. Children, tell me, when you add two integers, whether the sum will be always an integer? Yes, right? When you add two integers, the sum will be always an integer. Let's take an example and do it. Minus 3 plus 2. Minus 3 plus 2. What is the answer? Minus 1. Is it an integer? Yes. It is an integer. Correct? Minus 3 plus 2 equal to minus 1, which is an integer. So we say that integers are closed under addition. Integers are closed under addition. When you add two integers, the sum is always an integer. So we say that integers are closed under addition. Now what about subtraction? Minus 4 minus 5. Minus 4 minus 5 equal to, we have already studied the operation. Minus 4 minus 5 is same as minus 4 plus additive inverse of 5 is minus 5. Minus 5, and when you have to add two negative integers, just add the two integers without considering their sign. So it is 9 and put negative sign. Minus 9 is the answer. Is it an integer? Yes. This is also an integer. So when you have added two integers, you got the answer as an integer. Whereas when you have subtracted two integers also, you got the answer as an integer. So integers are closed under addition and subtraction. Integers are closed under addition and subtraction. Now let us take the case of multiplication. Minus 4 into minus 3. What is the answer? Minus 4 into minus 3. Answer is positive 12. This is also an integer. Okay? This is also an integer. So when you have added two integers, you got the answer as an integer. When you have subtracted also, you got integer. When you have multiplied also, you got an integer. So integers are closed under addition, subtraction and multiplication. But what about the case of division? When you divide two integers, whether the quotient will always be an integer? Let us check, okay? Minus 8 divided by 3. Minus 8 divided by 3. Is it an integer? No, it's not an integer. It's not an integer. It's not an integer. So always you won't get an integer when you divide two integers. Okay? So integers are not closed under division, but integers are closed under addition, subtraction and multiplication. This is closure property. Now let us move on to the second property. Commutative property. Commutative property. Okay? So here it is closure property with addition, subtraction, multiplication and division. Okay? Now let's move on to the second property, which is commutative property. If a and b are two integers, then a plus b will be equal to b plus a. Think. If a and b are two integers, whether a plus b will be equal to b plus a. Right? Will it be equal? Yes. Let us check. We will take an example. 6 and minus 2. 6 and minus 2. Two integers. Just add it. 6 plus minus 2 equal to, and minus 2 plus 6 equal to. Find out the answers. 6 plus minus 2 is equal to positive 4 is the answer. Correct? Minus 2 plus 6 is also positive 4. In both these cases, when you have changed the order and added, you got the answer as the same. If a and b are two integers, then a plus b is equal to b plus a. 6 plus minus 2 is equal to minus 2 plus 6. That means addition of integers is commutative. Addition of integers is commutative. Now, let's take the case of subtraction. 6 and minus 4. Okay? 6 and minus 4 are two integers. Let me go for 6 minus 4 and minus 4, 6 minus second integer. 6 minus 4 and take the second integer first. Minus 4 minus 6. Find out the answers. 6 minus 4 is equal to 6 plus positive 4, which is 10, whereas minus 4 minus 6 is equal to minus 4 plus, what is the additive inverse of positive 6? Minus 6. So you are getting the answer as minus 10. So here it is positive 10 and here it is minus 10. So if a and b are two integers, a minus b not equal to b minus a. But in the case of addition, we got that if a and b are two integers, then a plus b is equal to b plus a. So addition of integers is commutative, whereas subtraction of integers is not commutative. Okay? Now the third one is with multiplication. When you multiply two integers in any order, will it be equal? 6 into minus 3 and minus 3 into 6. They are equal, right? 6 into minus 3 is minus 18. Here minus 3 into 6 is also minus 18. In both the cases, you are getting the same product. That is, if a and b are two integers, then a into b is equal to b into a. That is, multiplication of integers is also commutative. When you have considered two integers like a and b, a into b will be always equal to b into a. Multiplication of integers is also commutative. What about division? Minus 10 divided by 2 equal to, and 2 divided by minus 10. Will it be same? Will it be equal? Minus 10 divided by 2 is minus 5. Right? Now 2 by minus 10, we will get the answer as minus 1 by 5. Minus 1 by 5. Whether these two are equal? No, they are not equal. That is, a divided by b not equal to b divided by a. A divided by b not equal to b divided by a. That is, division of integers is not commutative. Addition and multiplication of integers is commutative, whereas subtraction and division of integers is not commutative. Now we move to the third property, which is associative property. Associative property. Associative property. When you add three integers in any order, will it be equal? Children, tell me, will it be equal? Yes. Let me explain with an example. If a, b, c are three different integers, then a plus b plus c will be equal to a plus b plus c. Okay? A plus b plus c is equal to a plus b plus c. Okay? Take an example. Minus 3 plus 2 plus positive 4 is equal to minus 3 plus 2 plus 4. Let us check whether they are equal. Minus 3 plus 2 is minus 1. Minus 1 plus 4 equal to right side minus 3 plus 6. Here you will get the answer as positive 3. Here also you will be getting the answer as positive 3. That is a plus b plus c is equal to a plus b plus c. 3 integers can be added in any order. The answer will be always equal. So we can say that addition of integers is associative. Addition of integers is associative. Now next one is with subtraction. Okay. What happens when you subtract 3 integers in different order? Will it be equal? Will it be equal? Yes or no? Okay, let us check. Let's take 3 integers, 3, minus 2 and 4. Okay, so 3 minus 2 minus 4 is equal to 3 minus 2 is 3 plus 2 minus 4, that is 5 minus 4, which is equal to 1. Now just see 3 minus 2 minus 4. What will be the answer? 3 minus 2 minus 4. Minus 2 plus minus 4, which is equal to 3 minus 6. So you will get the answer as 3 plus 6, which is equal to 9. See the cases? In this the answer is 1. In the second one the answer is 9. That means if a, b, c are 3 integers, then a minus b minus c not equal to a minus b minus c. Okay? That is, subtraction of integers is not associative. Subtraction of integers is not associative. Now let us take the case of multiplication. Okay? When you multiply 3 integers in different orders, will it be equal? 3 into minus 2 into 5, 3 into minus 2 into 5. Same integers are used in both the sides, LHS and RHS, but the order is changed. So will it be equal? Let us see. 3 into minus 2 into 5 is minus 10. Here minus 6 into 5. Minus 30 is the answer on the left side, and here also it is 30. So we can see that when you have multiplied 3 integers in different orders, the answer is, the product is the same. That is, if a, b, c are 3 integers, then a into b into c is equal to a into b into c. Okay, so multiplication of integers is also associative. Now what about division? Will it be associative? No, right? Anyway, let's check. 3 divided by minus 2 divided by 5 is equal to what? Now next one, 3 divided by minus 2 divided by 5. Let's see this. 3 divided by minus 2 divided by my positive 5. Okay, now this case 3 divided by minus 2 divided by 5. So tell me what will be the answer here? In order to divide, you have to multiply the reciprocal of the second one with the first one. So 3 into minus 5 by 2 is the reciprocal of minus 2 by 5, which will give the answer as minus 15 by 2. And see here, 3 by minus 2 into 5 by 1. Its reciprocal is 1 by 5. And the answer is 3 by 10 minus 3 by 10. Answer is minus 3 by 10. You can see that the answers are different. So division of integers is not associative. Division of integers is not associative. Okay? If a, b, c are 3 integers, then a divided by b divided by c not equal to a divided by b divided by c. So this is the third property. Now let's move on to the next property, which is additive identity. Which is the additive identity for integers? Can you tell me? Additive identity for integers is 0. 0 is called the additive identity for integers. When you add 0 to any integer, the answer will be always the same integer. 0 is called the additive identity for integers. When you add 0 to any integer, you will get the same answer. 6 plus 0, 6 itself. Minus 10 plus 0 equal to 10 itself. So 0 is called the additive identity for integers. When you add 0 to any integer, the sum will be always the same integer. Okay, so next one is multiplicative identity. Which is the multiplicative identity for integers? Children, tell me. One is called the multiplicative identity for integers, because when you multiply an integer with 1, the product will be always the same integer. 1 is called the multiplicative identity for integers. When you multiply any integer with 1, the product will be always the same integer, right? Minus 3 into 1, minus 3. 6 into 1, 6. So 1 is called the multiplicative identity for integers. Now the next one is additive inverse, which we have already studied, right? If a is an integer, then minus a is its additive inverse. Additive inverse, which already you have studied, but still I will explain once again. If a is an integer, then its additive inverse is minus a. If you take minus a as an integer, then its additive inverse is positive a. So how will you obtain its additive inverse? Multiply the given integer with minus 1 and you will get the product, which will be the additive inverse of the given integer. For example, 3, its additive inverse is minus 3. 3, its additive inverse is minus 3. Or if you take minus 3, its additive inverse will be positive 3. Okay? So this is regarding additive inverse. Now the last property is distributive property. Distributive property. If A, B and C are 3 integers, then A into B plus C is equal to A into B plus C is equal to A into B plus A into C. A, B and C are 3 integers, then A into B plus C is equal to A into B plus A into C. A into B plus C is equal to A into B plus A into C. Okay, this is the distributivity of multiplication over addition. Now let me explain with an example. 3 into minus 2 plus 5. Either you can add these two, then multiply with 3, that is enough. Otherwise, we just multiply 3 with minus 2 by using distributive property. 3 into minus 2 plus 3 into 5, which is equal to 3 into minus 2 is minus 6 plus 3 5s are 15. So the answer will be positive 9, right? Minus 6 plus 15, positive 9 is the answer. And if you do with the same 3 into minus 2 plus 5 also, you will get the same. How it is? 3 into minus 2 plus 5. What is minus 2 plus 5? It is positive 3. So 3 into positive 3. Here also you will be getting the same answer. So A into B plus C, 3 into minus 2 plus 5 is equal to 9. Okay. Now we have written it as a into b plus a into c, or 3 into minus 2 plus 3 into 5, which will give the answer as 9 itself. So this is distributivity of multiplication over addition. Now distributivity of multiplication over subtraction is, if a, b, c are 3 integers, then a into b minus c is equal to a into b minus a into b minus a into c. Okay, now let us take an example. 3 into 5 minus 2. 3 into 5 minus 2 equal to, what is 3 into 5 minus, using distributive property, 3 into 5 minus 3 into 2, which is equal to 3 into 5 is 15, 3 2s are 6. Tell me, again you are getting 9? Yes, 9 is the answer. Without using distributive property, if you solve this, if you calculate this, you will get the answer as 3 into 5 minus 2, which is equal to 3 into, what is 5 minus 2? It is 3. So 3 into 3, which is equal to 9. Okay, so this is distributivity of multiplication over subtraction. So we have studied distributivity of multiplication over addition and subtraction. Okay, got it, children? You need some more examples? One more? Okay. Now let me give a question to verify the distributive property. Okay? Verify distributive property. Six into minus 3 plus 4. Okay, you have to verify the distributive property. You have to show that 6 into minus 3 plus 4 is equal to 6 into minus 3 plus 6 into 4. So let us check. What is 6 into minus 3 plus 4? Equal to 6 into minus 3 plus 4. Answer is positive 1, right? Yes. So 6 into positive 1. 6 into 1. 6 is the answer. Now just go for the right side. A into b plus a into c. 6 into minus 3 plus 6 into 4, which is equal to 6 into minus 3 is minus 18 plus 6 into 4. 6 4s are 24. Here 1 is negative, positive integer, subtract and put the sign of the biggest. Positive 6. Here also the answer is positive 6. So we have seen that 6 into minus 3 plus 4 is equal to 6 into minus 3 plus 6 into 4. We have proved that a into b plus c is equal to a into b plus a into c. So we have verified the distributive property, multiplication over addition. I hope all understood. Okay.